I'm going to be doing a review of a concept that I noticed a lot of students missed out on when you were doing the practices from last week. Overall, you guys did a great job with heterozygous and homozygous and knowing which genotype is which. You've done a great job of knowing how to fill in a Punnett square. You did a great job of being able to predict which genotype will lead to which phenotype. But I noticed a lot of students were confused about where that probability came from, where the percentage was coming from. So we're going to go over that today. So first thing I want to review is remember that a Punnett square is a tool to figure out the probability, the chance of getting a trait. What is the percent chance that my baby will have freckles? And we can represent this in a bunch of ways. I noticed a lot of students liked doing this in percentages, so we're going to focus on percentages today. So a quick reminder lesson about percentages. When we look at percentage, we're looking at parts of a whole. So if we're looking at the whole circle, this is 100%. If we were to take that circle and divide it in half, each half would be 50%, and then this half is 50%, which adds up to the whole. If we take the circle and divide it into 4, each quarter, each 1/4 of this circle is 25%. And that's as far as we need to go to understand our Punnett square. Because our Punnett square has 4 possible outcomes. The whole Punnett square is 100% of the babies we could possibly have. Each individual square is 25% of the chance. So that's why we used our Punnett square to represent the probability. So let's set up this Punnett square and let's look at how we would do this example. So I'm using this example, which came from the notes sheet from last week. And it was freckles versus no freckles. So I said we're going to cross somebody who is heterozygous for freckles with somebody who is homozygous for no freckles. So I'm going to put I'll put one parent across the top. Their alleles are on the top. One parent on the side, and you guys did a great job of knowing how to do this last week, so I'm not going to spend a ton of time, but just remember that you're going to take the allele on the top of the column and the allele on the side of the column. Oh, that should be an F. And then you're going to put it in the box. So here's what we end up with. Let me go quickly. And now this is where some students got stuck. You could tell me that this would be no freckles and that this would be freckles. But like, how do we fill in this table? Where do these percentages come from? So that's what we're going to look at. So the first thing we want to look at in this table is what are the possible genotypes that we could have? Well, in this example, if I look at all the possible phenotypes, I see that there's 2 phenotypes I can have. I can have big F, little f, and I can have little f, little f. So I'm going to put those in my table. Now, here's a step that can help you figure out the percentages, and that's color coding this table. And you can do this in a Google Doc just by selecting the squares you want, finding the paint can, and then picking a color. So let's color code. I'm going to say that both of my heterozygous genotypes for my potential babies, I'm going to color code them blue real quick. Color these blue really quickly. So, can you see that on the camera? So there are 2 boxes that have the genotype, big F, little f. And then my little f's, I'm going to color these yellow. So both these boxes have little f, right? And I can even, if I wanted to, even color code my table. So now, this will help me see what percentage of my boxes have a particular trait. So as I go across, let's see. Big F, little f, this would be heterozygous. And because I know that freckles is the dominant trait in this example, because this kid has at least 1 copy of the dominant allele, the phenotype, remember phenotype is going to be your trait, is going to be freckles. Now let's look at the probability. Now that I've color coded, now I can easily see of these 4 squares, how many have the trait? How many will have this phenotype of freckles? Well, it's 2 out of my 4 squares. And just as we said before, 25% each. When we divide a circle into 4, each square, each fourth is 25%. So each of these squares represents 25%, 25%, 25%, and 25%. So basically all I have to do is add up how many have this trait. So 2 squares, 25% plus 25% tells me I have a 50% possibility of having a kid with freckles. So then we do the same thing down here. This would be homozygous. It would have no freckles because it's got 2 copies of the recessive. And again, I go back up to my Punnett square. I look at how many squares have this trait. So there are 2 squares that have the little f, 25% plus 25% is a 50% chance. Here's a tip. This should always add to 100%. However many possible genotypes you have, the total has to be 100% because, right, we have 100% of the possible babies. So let's look at a second example, and I'm going to go through this fairly quickly. If this gets confusing for you, you should be coming to Science Live. So I'm going to look at, this is an example from the second practice from last week. I'm looking at a cross between 2 heterozygous flowers. So the opposite, the recessive trait, is white flowers. So that would be little p, little p. But we're looking at a cross of 2 similar parents, both purple flowers, both heterozygous. So I'm going to put P, 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 P. I don't know if you can tell the difference between capitals. So I'm going to fill in my Punnett square. Trying to make a big difference between my capitals and my lowercase. So there's my Punnett square filled in. We're going to do the same thing this time. How many genotypes do I have this time? Well, I see I've got big P, big P, little p, and, well, this is the same. Then I have little p, little p. So let's color code these again. Let's take blue. Blue, I'm going to color code my box that has big P, big P. I can use orange for big P, little p. And that's both of these boxes. They have the same genotype. And then I have yellow for little p, little p. Now I can see, of the 4 boxes in my Punnett square, this is how many of each one has that trait. I'm going to go down to my table. I have basically 3 possible genotypes. So my 3 genotypes are big P, that's the blue one, big P, my orange one, and little p, little p. Okay, and so these 2 are homozygous. This is hetero. And let's see, this would be purple, and white. So you guys follow that part so far. Okay, now I need to know for each of these genotypes, what is the probability? Well, for big P, how many squares do I have? And since I know that big P is the one that I color-coded blue, I look for how many blue squares I have. I have 1 blue square. Because each of these squares is 25%, I know that my probability for big P is only 25%. 1 out of every 4 babies is likely to have that genotype. Then if I look at big P, little p, I can look at the same thing. Well, this one is my orange squares. How many orange squares do I have? I have this one, and I have this one. So this is 25% over here, but also 25%, which means my total is going to be a 50% chance that one of their babies is going to be heterozygous for the dominant trait. And lastly, I have my yellow square, my little p, my 1 chance of white flower. Because there's only 1 square, it's a 25% chance. So in this case, these are the chances of each individual genotype. But I might ask, what is the overall chance of getting a purple flower? Well, I'm going to have to look at both options that could give me purple flowers. Since both of these genotypes, big P and big P little p, will give me a purple flower, I'm going to have to add these two together. Overall, 50 plus 25 is 75%. So these are the chances of getting these genotypes. If I'm asked about the purple phenotype, the chance is actually 75% because all three of these potential offspring would have purple flowers. This is where percentages come from. If this is still confusing for you, please make plans to come to one of my Science Live sessions. I am on at noon every day from noon to 12:30, and I'm there the whole time. You don't have to be there right at noon. I just keep it open and talk to anyone who comes. And if you aren't able to make it to one of those, please set up a time with me when we can go over this. I'm happy to go through a bunch of examples of this with you. Students I've gone through this with have told me that it has been helpful. So please reach out to me, get help. Thursday, your assignment is to do a formative assessment on a Google form where you're doing exactly this. So you want to be prepared for that. Okay? Reach out to me, please. Email me. Don't call me, but email me or whatever you need to do to get help. All right. See you all this week. Bye.